If f is the PMF for a discrete random variable, we can find the mode by computing values until we find the greatest, or computing the quotient and finding where the quotient switches from being greater than 1 to being less than 1. We could find formulas for the modes of some common distributions, but we won't. Remember, understand concepts. Don't memorize formulas. For example, suppose each person in a population has a probability of having a certain disease. If people are tested until somebody with the disease is found, what is the mode of the number of people tested? This is a geometric distribution with probability of success 0.0625. And so the ratio between consecutive probabilities will be and notice that this ratio is always less than 1. This means that as k increases, the probabilities get smaller. So the probability x equals 1 is greater than the probability x equals 2, which is greater than the probability x equals 3, and so on. And so x equals 1 has the greatest probability, and it will be the mode. Now, in general, when the ratio equals 1 might correspond to the mode, but it's possible that it might correspond to the least probable outcome. So we should verify that it gives us the most probable outcome. But all of the common discrete probabilities increase, then decrease. So when the ratio equals 1, the probability will be the greatest. So for example, suppose we have a group of 18 patients, and each patient has an independent probability of 0.15 of testing positive. Let's find the mode. So this is a binomial distribution with n equals 18 and p equals 0.15, so the probability of any specific outcome is, and the ratio of the probability x equals k to x equals k plus 1 will be, which we can simplify to this ratio is equal to 1 when Now let's think about this carefully. This means the ratio between the probability of k plus 1 and the probability of k will be greater than 1 until k reaches 1.85. Now, while the formula makes sense for any value of k, the probabilities only exist if k is a whole number. So if we take k equal to 1, this ratio is greater than 1, and so the probability that x equals 2 is greater than the probability x equals 1. And since we know the binomial probability increases, then decreases, this means our probabilities will increase until we get to x equals 2. Now consider this ratio. Since 2 is greater than 1.85, this ratio must be less than 1. And so that says the probability x equals 2 is greater than the probability x equals 3. Consequently, the binomial probabilities begin decreasing, and since they don't switch to increasing again, this means they'll continue to decrease, and so the probability x equals 2 will be greater than the leading probabilities. And so we know the probability x equals 2 is greater than some, and greater than the rest, so x equals 2 is the most probable outcome, and consequently the mode is also equal to 2. Or let's consider a Poisson distribution. So the probability of x equals k accidents will be, so the ratio of consecutive probabilities will be So remember, the Poisson distribution increases, then decreases. So the value that makes the ratio equal to 1 corresponds to the mode. And so the ratio is equal to 1 when and so the mode is 7. Or is it? Since the ratio is 1 at k equal to 7, this means the ratio between the probability that x equals 8, 1 more, and the probability x equals 7 is 1, and so the probability that x equals 8 is equal to the probability x equals 7. And since these are equally probable and the most probable outcomes, this distribution is bimodal with modes 7 and 8. Or let's consider another problem. Now this is a negative binomial probability with the probability of damage 0.4 and the number of occurrences are equal to 2. And so the probability that the home will sustain damage R equals 2 times in k hurricanes is our negative binomial probability. And the ratio between successive outcomes will be this ratio is equal to 1 when and again, like all the others, the negative binomial probability increases, then decreases. So k equals 2.5 is going to correspond to a maximum value of the ratio. So now consider this quotient. This has to be greater than 1 since 2 is less than 2.5. And so that tells the probability that x equals 3 is greater than the others. And likewise, this quotient has to be less than 1 since 3 is greater than 2.5. So again, probability x equals 3 must be greater than the rest. And so x equals 3 is the most probable value, and so the mode is 3.